Hello everyone, now we are going to solve the questions based on the punching press. A machine punching 38 holes in 32 thick plate. Okay, what is given in the question? The hole size is 38 in 32 thick plate. Requires 7 Newton meter of energy per square of shaded area. Okay, so here the area is given. That means suppose this is a plate. Okay, we need to understand it. This is basically a plate and there is a punching operation which is going to be take place here, and it is saying that the punching 38 holes. 38 means the diameter of the holes is given. The diameter of the holes is 38 okay, and 32 thick. That is the thickness of the plate is 32 32 So we can calculate here the sheared area. The shearing take place here when punching take place. Punching means the shearing portion which is going to be sheared area. So here I can calculate the sheared area, that is pi dt. So that would comes out to be pi multiply 32 multiply 38. Okay, so when you calculate this you will get the value of shaded area, and that would comes out to be 3820 square. Okay, so this is the shaded area. Now a plate requires 7 Newton meter of energy per square That means if I want to find out the energy required to punch a hole, so you can write here the energy required to punch the hole. Energy required to punch one hole. To punch a hole, you have to read the question carefully. Okay, then you will be able to understand the concept of the punching press. So the energy required to punch a hole is 7 Newton meter per square. Okay, so we can multiply with area, so we will get the value of energy, that is E1. I'm considering E1. 7 multiply what is shaded area, that is 3820, and you will get the value of energy requirement. Okay, so that would comes out to be 26740 Newton into meter. Okay, so that is the energy requirement for the punching 26740 Newton into meter. Now also the time required to punch a hole is 10 seconds. What is it is saying in the question? Punches on holes in every 10 seconds. That means in every 10 seconds one hole is going to be punched. Okay, so this is basically the cycle time. You can see here, this is the plate here. The punch will move in the downward directions and move in again in the upward direction. So this is basically the punching time. This is not a punching time. Basically it is saying that it punches holes in every 10 seconds. That means when one stroke is completed, another stroke is going to be completed, then the next stroke, then the next stroke. Okay, so like that, this is talking about the cycle time. This is not the punching time. Punching time is always less than the cycle time. So it is saying that after 10 seconds another punch take place, and after again 10 seconds another punch take place. Okay, so this is not punching time. This is saying that after every 10 seconds the punching is going to be take place. So punches hole in every 10 seconds, and calculate the power of the motor required. Okay, so we can calculate the power of the motor. Then the mean speed of the flywheel is given, that is 20 meter per second, and the punches has a stroke. Now see here, the cycle time is given 10 seconds. Okay, after 10 seconds another stroke is happening. Okay, so that means stroke is given, that is 100 So if stroke is 100 that means 100 is covered in 5 seconds. Why I'm writing 5 seconds? See here, this is our plate. Okay, for example, punch will move in the downward directions, again will move in the upward directions. Okay, this is complete one stroke. Remember, this is half stroke and this is half stroke. This is completed one stroke. That means this is 100 mm. Okay, so 100 mm is covered in 10 seconds. That means 200 mm. This is 100 mm and this is 200 mm. Okay, so 200 mm. Are you getting my point? This is 100 mm and this is 100 mm. Okay, and it is saying that the punch has a stroke. That means this is a stroke and this is complete the stroke. Okay, so there are 200 mm is covered by the punch. Okay, in 10 seconds, because after every 10 seconds there is a punching. Okay, so that means 200 mm, 200 mm is covered in, and I'm just writing here, 200 mm is covered in 10 seconds. That means 100 mm is covered in 5 seconds. Okay, so you can see here 1 mm is traveled in 5 by 100. Okay, so if the thickness of the plate is, if the thickness of the plate is 32 mm, this is 32 mm, so 32 mm is covered in 5 by 100 multiply 32, and it would be our punching time. That would be 1.6 second. That is nothing but the punching time, because punching size is 32 mm. So the time covered, the time travel for 32 mm, that would be 1.6 second. That is nothing but the punching time. So you can see here that punching time is less than the cycle time. Okay, the cycle is completed in 10 seconds. Okay, so you can see here the punching time is 1.6 second. So from here we can get the value of power of the motor, because we know that the energy required is 26740. Okay, this is energy required to punch a hole. So this is in Newton meter, and if I want to calculate the, if I want to calculate the power of the motor, power of motor, this would be equal to energy required, energy required to punch a hole in 10 seconds, energy required to punch a hole in a second. So you can find out the power of the motor. Power of motor, that would be equal to 26740 upon 10. Okay, this is the energy required to punch a hole, and we know that every hole is taking place in 10 seconds. So this would be the 2674 Newton meter per second. Basically this is the power of the motor. In kilowatt you can write it as 2.674 kilowatt. Okay, so the first part is completed. In the second part, what is asking in the second part? In the second part, it is asking that find the mass of the flywheel required if the total fluctuations of the speed is not exceed to 3% of the mean speed, and assume that the motor supply energy to the machine at uniform rate. Okay, see here, we need to find out how much amount of energy is going to be accepted from the flywheel. We know that total amount of energy that is required is 26740. E1 is energy required, that is 26740 Newton into meter. Okay, and what is E2? E2 is nothing but the energy supplied by motor. I'm writing here that energy supplied by motor, energy supplied by motor in 1.6 second, because 1.6 second is the punching time. So energy supplied by the motor in 1.6 second, that would be E2 is equal to 2674 multiply 1.6, and you will get the value of that would be 4278 Newton into meter. Okay, so we know that this is the energy supplied by the motor in 1.2 second. Okay, so we can calculate the energy that is to be supplied by the flywheel during the punching, or you can say the maximum fluctuations of the energy. So I can calculate here maximum fluctuations of the energy, that is the energy supplied by the flywheel. So maximum fluctuations of energy, that would be delta E is equal to E1 minus E2. Okay, E1 is the energy required, that is 26740 minus 4278, and you will get the value of delta E, that would be 22462. Okay, Newton into meter, that is the energy supplied by the flywheel. And we are close to answer. We all know that delta E is equal to I omega square Cs. I omega square Cs. What is the value of Cs? Cs is already given in the question, that is 3%. If it is 3%, that means it is equal to 0.03. Okay, and what is the value of omega? Omega is not given. We know that V is equal to R omega, because V is given in the question. You can see here 25 meter per second, that is the value of V. V is given. Omega we can calculate, or we can replace omega with the V. Okay, and we know that I is equal to mk square, that is m k square. Okay, so here you can see that if I write omega square means V square upon R square. Are you getting my point? So you just have to know that radius of gyration on the another side, that radius of gyration is equal to R by under root of 2. That is for disk. Okay, unless and until it is mentioned that the flywheel is a ring, you just have to consider flywheel as disk. Okay, in general flywheel as considered as disk, so you just have to apply the radius of gyration for the disk, that is R by root 2 for disk. Okay, if it is mentioned in the question that the flywheel is a ring, then you can apply that radius of gyration k is equal to R by what would be k is equal to R, but it is not mentioned in the question that the flywheel is disk or ring, so you just have to consider the flywheel as a disk. So we know that the radius of gyration for the disk k is equal to R by 2, so you just have the value, that is I is equal to m R square by 2 here. Now we just have to put the value in these equations, that is m R square by 2. So m R square by 2 multiply V square upon R square, V square upon R square multiply Cs. Okay, so this would be cancel out, and you can see here that is m V square Cs upon 2. So you will get the value of mass is already given in the question. Sorry, mass we have to calculate. Okay, so mass we have to calculate, and delta V we have calculated. So that would be delta V is 22462. 22462 is equal to m is I'm again repeating that if in the question it is mentioning that the flywheel is a disk, then you have to apply this formula, because we know that for the disk radius of gyration is R by root 2. Okay, you can assume it as a disk in general. Okay, so I'm assuming that the flywheel as a disk, so I'm applying this is the mr square by 2, so that would be m. We have to calculate, we already given in the question, that is V is 25 meter per second, so that is 25 square by 2, and Cs is 0.03. So you can calculate the value of mass here. Okay, so that would be 95.94 kilogram. Okay, so this would be the final answer. Thank you.